Hello everyone and welcome back to our videos. Today we will talk about pressurization systems. Flight is most efficient at high altitudes where the air is thin and the aerodynamic drag is low. In order for humans to fly at these altitudes, the aircraft must be pressurized and heated. Pressurization problems. Turbine engines operate effectively at these high altitudes. Piston engines as well as human occupants of an aircraft require a supply of additional oxygen. Piston engines were limited to relatively low altitudes and did not require a high cabin pressure, so no great structural problems showed up with pressurized piston engine airplanes. Metal fatigue caused by the repeated pressurization and depressurization cycles caused several disastrous accidents. Today, aircraft structural design has advanced to the point that pressurized aircraft are able to safely and comfortably carry large loads of passengers at efficiently high altitudes for long distance flights. Most cabin pressurization systems have two modes of operation. The first mode is isobaric mode, in which the cabin is maintained at a constant altitude. Iso means same and baric means pressure. The second mode, constant pressure differential mode. In isobaric mode, the pressure regulator controls the outflow valve as the aircraft goes up in altitude to maintain the same pressure in the cabin. When the pressure differential between the inside the cabin and the outside reaches the maximum structural pressure limitation, the pressure controller shifts to the constant differential mode and maintains a constant pressure differential. As a flight altitude increases, so does the cabin altitude, always maintaining the same differential pressure between the inside and the outside. Sources of pressurizing air. The pressurization of modern aircraft is achieved by directing air into the cabin from compressor section of a jet engine and cold bypass. A second one is a turbo supercharger and it comes from the exhaust gases. The third one, an auxiliary compressor. Reciprocating engine aircraft. Pressurization air for smaller piston engine aircraft is provided by bleed air from the engine turbocharger. Turbine engine aircraft. The compressor bleed air in a turbine engine is a good source of air to pressurize the cabin and Since the air is quite hot, it's used to provide heat as well as pressurization. Compressor bleed air may be used directly or it may be used to drive a turbo compressor. Outside air is taken in and compressed, and then before it enters the cabin, it's mixed with the engine compressor bleed air that has been used to drive the turbo compressor. A jet pump flow multiplier can provide cabin pressurization air without the complexity of turbo compressor. Compressor bleed air flows through nozzle of a jet pump at high velocity and produces a low pressure that draws air in from the outside of the aircraft. The bleed air and the outside air mix and flow into the cabin to provide the air needed for pressurization. Control of cabin air pressure. There are two types of leakage in an pressure vessel: controlled and uncontrolled. The uncontrolled leakage is the air that escapes around door and window seals, control cable, and openings. Pressurization control system can be of the pneumatic or electronic. Pressurization cockpit controls. Most pressurization systems have cabin altitude, cabin rate of climb, pressure differential indicator. The cabin altitude gauge measures the actual cabin altitude. The cabin altitude is almost always much below that of the aircraft altitude, except when the aircraft is on the ground. An example would be an aircraft cruising at 40,000 feet would normally have a cabin altitude of about 8,000 feet. The cabin rate of climb indicator allows the pilot or flight engineer to adjust the rate the cabin altitude is climbing or to levels that are comfortable. For normal climb rate is 500 feet per minute. Normal descending rate is 300 feet. The cabin rate of climb can be automatic or manual according to the type of aircraft. The differential pressure gauge reads the current difference in pressure sure between the aircraft's cabin interior and the outside air. If the cabin altitude exceeds 10,000 feet, an alarm will sound, alerting the flight crew to take action. In this figure, we have the three indicators. This, the cabin altitude. Here, this we have the rate of climb, and this, the differential pressure indicator.